welcome everybody. We are now going to look at how atomic theory affects us. What do we need to know about it? We have this history where we started with the Greek philosophers giving us an idea of the atomos, about these incompressible, hard structures that make up matter. And that was in the 5th century BC or BCE, before Common Era, all the way through to around about 1927 when Schrödinger came up with his equation. And obviously the atomic theory has developed since then. So it's quite a substantial amount of time that we have this theory that stands, and it is solid today. So let's look at what we need to know about the atom. On my screen here, I have a picture of the atom, and you'll see it is a picture. It's a diagram, and it shows the nucleus way bigger than it really should be. So that's the first thing to note, that in the center of the atom, this area over here, we have what is called the nucleus. Now the nucleus is the heavy part of the atom. Inside the nucleus, we've got subatomic particles. We have got the proton, and the proton is a positively charged particle. It is positive. It also has mass. Okay, so it has a certain amount of mass, and we're going to go into the mass and how we work all that out. In the nucleus, we also have something which is called the neutron. Now, the word neutron, from neutral, is saying what it is. So a neutron is a neutral subatomic particle. It's found in the nucleus, but it has mass too. So it has no charge, but it does have mass, and it has the same amount of mass as a proton. This has an implication for us. We will come to that in a few slides' time. So the nucleus is really the center of the atom. It is extremely small, unlike this diagram. It is extremely small. It's made up of protons and neutrons. Now, we sometimes use a different word, which is a nucleon, and I'll write that down, nucleon. And a nucleon is referring to either a neutron or a proton. So we call nucleons, they are just the subatomic particles that we find in the nucleus. The greater part of the atom, the greater volume of the atom, is made up from the orbitals of the electrons. So the electrons are the little tiny particles that are whizzing around, creating the space around the very small heavy center, the nucleus of the atom. So here we have the electrons depicted. So those are electrons. They are very small. They have negligible weight. Their mass is incredibly small. They are negatively charged. And as with our theory that we have talked about, if an atom is neutral, then there will be equal number of positives protons and negatives electrons. So that is what we work from, our baseline. We work from the fact that an atom is neutral. It has equal number of protons and electrons. So what happens if an electron is added? And that happens in a chemical reaction. So when there's a chemical reaction between atoms, the electrons are added, or they are removed, or they are shared. And so we are going to consider electrons being added. So if we add an electron to this atom, to its valence shell. The valence shell is the shell that's on the outside, the very, very outside of the atom. Inside, we talk about core electrons, so those are the electrons around here. So that would be the electrons on the inside. The valence electrons would be the electrons on the outside, in the outermost energy level or orbital. So if we add an electron to those valence electrons, what's going to happen? That atom is not going to be neutral anymore. It is going to gain a negative charge. And when it gains a negative charge, we can't call it an atom anymore. It is then called an ion. So an ion, spelt like that, is an atom that has either gained electrons or has lost electrons. So an ion is a charged atom by either gaining or losing. Gaining or losing electrons. Okay, I'm going to write it like that, a little e with a line across the top. So, when we have got, in this case, if we're adding electrons, it's becoming more negative, and that particular ion is called something specific, and it is called an anion. So I'm going to just change my color so that we can see the difference here. An anion, and I'm going to write it here, anion is the ion that has gained negatives, gained electrons, and it is negative. Okay, so it is a negatively charged atom, which we now call an ion. What happens if I take away, or electrons are taken away? They're taken away in a chemical reaction from the valence shell. What happens then? Well, then we don't have a neutral atom anymore. Then negatives are removed, and so there are going to be less negative charges, and our overall charge on this atom is going to be positive. It is still an ion. It is now an ion, only it is positively charged. And so this specifically is called a cation. Okay, cation, C-A-T-I-O-N, a cation, and that is one which is positively charged. Okay, it is positive. So, whoops, my spelling is a little bit weird. I hope you can see that. So, we really need to get a good idea of this neutral atom. Equal number of protons, equal number of electrons. The positives and the negatives are equal in number, and so the charges cancel each other out. It becomes neutral. It's a neutral atom. If we take away electrons from the valence shell, then we are unbalancing the positives and the negatives. There are now less negatives, and so we get something which is positively charged. It is called an ion because the atom doesn't have its full complement of electrons, and it is called a cation specifically because it is positively charged. If we add electrons to that valence shell, the number of electrons has now changed, and so there are more electrons than originally, and that is then called an anion because then there'll be more negative charges than positive charges, and so the overall charge is going to be negative. So it's an anion. It's an ion now with a negative charge. I hope you get that. Right, let's move on. What about our particular atom? We're taking a single atom, and in this picture I have hydrogen. Now hydrogen is a very teeny little atom. The hydrogen element has got one proton. You can see in the center of the nucleus, excuse me, and it's got one proton. You can see it is a neutral atom because it has got one electron. There's one proton, one electron. Now, as scientists started to try and work out mass of each atom, of each element, it was quite difficult work, and they had to do some amazing experiments to figure this out. But this is what they found. They found that the mass of a proton is the same as the mass of a neutron. The person who found out the neutron is Mr. Chadwick. He discovered that subatomic particle, the neutron. So they found that the mass of the proton, the mass of the neutron was the same. Now, they used the proton as the reference point. Okay, so one proton, what are we going to call one proton? It's got mass. So they called it this. They said that it was equal to 1. So one proton is 1 AMU. Now, AMU stands for atomic atom mass unit. Atom mass unit. Okay, so they're saying one proton has mass, therefore we're going to say that one proton is 1 AMU, 1 atom mass unit. And they write it like this, 1U, so that U is the unit. Okay, it's, U stands for unit, and so it is the unit of mass of the proton. Later on, when they really looked at the precision, the detail around this, they discovered that 1 unit, in other words, the 1 atom mass unit, that's the mass of one proton, was 1,7 times 10 to the minus 27 kilograms. That is extremely small. The mass of an electron was even smaller, like way, way smaller. And you can see this is 1 over 1,840 units, or atom mass units. That is frightfully tiny. That is like not even worthwhile measuring. It is so small. And so we can see from that the mass of the atom is reliant, dependent on the mass of the proton, really, at the end of the day. The electrons don't have much say in the mass of this particular atom, or of atoms. What about diameter? So diameter we know as being the distance from the one edge to the other edge of a circle, and this is a spherical piece of matter. So the diameter of hydrogen they give as 0.37 angstrom. You'll see that it's an A, a capital A with a little bubble on top. And what is an angstrom? Well, it is times 10 to the minus 10 meters, which is also frightfully small. Right, I think it is time for a break.